Understand about the material for that phase diagram is going to be the must. This phase diagram, if you look about that, initially it is obtained by the purely experimental techniques. So in the experimental techniques, what we did is we identified that various temperature and various composition, what are the phases are present, what temperature it melt, and when it is going to get the reactions, all these things, and we connected these nodes by which we got the phase diagrams. So that was a really good. If it is look for the binary and ternary, it is going to be good. If you are going for more than 2 or 3 elements, it is become complicated. The another approach is going to be the completely a theoretical technique like a cluster variation method to construct the phase diagram based on the materials properties or based on the pure elements. It is actually in the developing stage. The cluster variation method able to satisfy the binary, and they started for the ternary, but it is not yet to come to that satisfactory level. It is still in the developing field. Next one is going to be the semi-theoretical. That is about we are going to combine about the limited number of experiments and theory, extrapolate and also interpolate, complete the phase diagram. And the main advantage of this one is it is not only going to take about the constitutional information, it is also going to take about the thermodynamic information. So if we are giving input as a thermodynamic information, after construction of the phase diagram, we are able to extract the, in addition to phase diagram information, thermodynamic information also we are able to extract. That is going to become an advantage, and we are able to handle the multi-component, multi-phase systems. So initially, if you look about that in the CARFAD approach, only a few group of people, now it is well versed in most of the countries. If you look about that, that is going to become a compulsory software. Before going to starting the system, they are analyzing that for the material design. If you look about this CARFAD approach, we have to understand how it is going to work. In the CARFAD approach, we are going to give about the phase equilibria information, that is about liquid, solid, phase boundary, at what temperature, what phase is going to be present, and thermodynamic information or thermochemical information, which is directly or indirectly related to the Gibbs energy, and crystallographic information. If you look about this, all this phase, whatever we are talking, we are going to express mathematical equations. Then in that case, that expression has to give about all these details. So crystallographic information is also going to be an input. So we are going to, with this input, we are going to model the Gibbs energy of all the phases which is present in the system. That is going to become developed as a database. Then it is going to be used as an application. Now if you look about this database is going to become important. So if you look about that, whatever we are talking about the Gibbs energy modeling, some of the metastable or unstable phases, initially people are used as an empirical parameter, and now people are going for the first principle method by giving input for the Gibbs energy modeling. Now I am mentioning about the Gibbs energy modeling, so we should have an idea. These Gibbs energies are going expressed as a power series like A plus BT plus CD LNB and something. So if you look about that A, B, C are the coefficient, these are all when they are developing the database, they are going to find this unknown variable that is about the coefficient with respect to the experimental data. Okay, so they have to map it in such a way they have to develop. This is the thing we are talking about, the Gibbs energy expression.
Sorry, ma'am, to interrupt you in between. Ma'am, I think you haven't shared your PPT, so we are just having a video only.
Will you repeat? I'm sorry.
I'm saying that your PPT is not visible. Have you shared that PPT?
Oh,
Your slides are not in the presenting form. That's what I'm saying. Yeah,
now are you able to see?
yeah, ma'am.
Okay, I'm sorry. So if you look about this is the one I'm talking about, this Carfad approach. And the next one, if you look about, this is the flow chart I'm talking about this. So these are all the input, thermochemical information, crystallographic information, phase equilibrium information. This is going to become an Gibbs energy modeling. This Gibbs energy modeling are going to be expressed these kind of equations. So if you want to look about that how it is going to be, this is going to be of the formula. So GHSCRC, so Gibbs energy at enthalpy at 298 Kelvin, standard element reference state of the carbon. This is Gibbs energy expression for the carbon, which is in the graphite crystal structure. This expression is valid between 298.15 Kelvin, that is from the room temperature, up to the 6000 Kelvin. Okay, so this A plus B, D, C, D, L, and D. Now you are able to see about the various numbers, that is about the coefficient which are identified. So